When fx equals ax squared plus bx plus c, the graph of y equals fx has a curved shape called a parabola. The coefficient of x squared determines the overall shape of the graph. When a is positive, the parabola will have this shape. When a is negative, the parabola will have this shape. The graph crosses the y-axis when x equals to 0. So when x equals to 0, the y-coordinate is equal to c. And the graph crosses the x-axis when y equals to 0. So the x-coordinates are the roots of the function fx. Quadratic graphs have one turning point. This can be a maximum or minimum. Since a parabola is symmetrical, the turning point and the line of symmetry are halfway between the two roots. You can find the coordinates of the turning point of a quadratic graph by completing the square. If fx equals a, x plus p squared plus q, the graph of y equals fx has a turning point of minus p and q. Y equals x squared minus 6x plus 8. As a equals to 1 is positive, the graph has the shape shown below and a minimum point. When x equals to 0, y equals 8, so the graph crosses the y-axis at 8. When y equals to 0, the graph crosses the x-axis. To find the x-coordinates of the graph when it crosses the x-axis, set y equals to 0 and then factorize. So x squared minus 6x plus 8 equals to 0. Factorizing gives us x minus 2, x minus 4 equals to 0. X equals to 2 or x equals 4. So the graph crosses the x-axis at 2 and 4. Since this graph has a minimum point, to find the coordinates of that turning point, complete the square. So completing the square of x squared minus 6x plus 8 gives us x minus 3 squared minus 1. So the minimum point has the coordinates 3 and minus 1. Now as you can see, this is the graph of y equals x squared minus 6x plus 8. Y equals minus x squared plus 6x plus 7. As a equals minus 1 is negative, the graph has a shape shown below and a maximum point. When x equals 0, y equals 7, so the graph crosses the y-axis at 7. When y equals 0, minus x squared plus 6x plus 7 equals 0. Factorize to find the coordinates in which the graph crosses the x-axis. So, x plus 1 minus x plus 7 equals 0. Then x equals minus 1 or x equals 7. So, the graph crosses the x-axis at minus 1 and 7. You can see the graph to find the points in which it crosses the x and y axis. Completing the square of minus x squared plus 6x plus 7 gives us minus 1 x minus 3 squared plus 16. So the coordinates of the maximum point are 3 and 16. This is the graph of y equals minus x squared plus 6x plus 7. Y equals minus 2x squared plus 4x minus 3. When x equals to 0, y equals minus 3, so the graph crosses the y-axis at minus 3. To find the coordinates in which the graph crosses the x-axis, set y equals to 0. You cannot factorize this, so use the quadratic formula to find the roots of minus 2x squared plus 4x minus 3 equals to 0. So, x equals minus 4 plus or minus the square root of minus 8 over minus 4. You cannot take the square root of a negative number, therefore this equation has no solutions, so the graph does not cross the x-axis. Completing the square of minus 2x squared plus 4x minus 3 gives us minus 2x minus 1 squared minus 1. So the coordinates of the maximum point is 1 and minus 1. As you can see below, this is the graph of y equals minus 2x squared plus 4x minus 3. Now, let's take a look at this example. A quadratic graph in the form y equals ax squared plus bx plus c crosses the x-axis at 3 and 5 and y-axis at 15. Find the values of a, b and c. When x equals to 0, y equals c, so c equals 15. The graph crosses the x-axis at x equals 3 and x equals 5, so the factors must be x minus 3 and x minus 5. So, y equals x minus 3, x minus 5 gives us y equals x squared minus 8x plus 15. So, a equals 1, b equals minus 8 and c equals 15. It was pretty simple to find the graph here by factorizing and expanding, but in some cases it is not very straightforward.